welcome to my channel Classic Coding Studio. I am KK Singh and today I am going to discuss on TrainTest split function in machine learning. So as far as TrainTest split is concerned, as the name says that it has to train the model and test the model, and for that we'll have to split the data into two parts. So what is in today's agenda, we'll be seeing it here. So in today's agenda, we have 10 test split demonstration, and we'll also do some practicals on 10 test split. So see here, what is the train test split function. So as far as function is concerned, so train test split is a scikit-learn class that help us to split the data into four data sets like xtrain, xtest, ytrain, and ytest. So here x and y train and test, four data sets are involved. So what are x and y? So as far as regression is concerned, we should have two important variables. One should be the dependent variable and one should be the independent variable. So independent variable, I am taking x as the independent variable, whereas I am taking y as the dependent variable. So what about x train and y train? So this is a job of a train test split function to divide the data into four data sets. One is x train and xtest, and second one is ytrain and ytest. So x is independent and y is dependent variable. So the entire data set is divided into four different data sets or sub data sets. So why are we dividing this data set? This data set is being divided into parts just because of part of the data, the big part of data will be used to train the model, and the small part of that data will be used for testing the trained model. So this we will see through the presentation. Have a look on this. So here I have taken a data set car prices. So this is car prices data. So over here we see there are three columns. One is mileage, second is sale price, and third one is age in years. So if you see and minutely observe this, then we'll find mileage and age years are independent variables, because as the vehicle moves, its mileage automatically increases. Similarly, with time, age increases. But on the basis of the mileage or the age, sale price is determined. So what we have done here, we have taken a complete data set, and out of the complete data set, we have divided the data set into two parts. One part is the 80% part. This is we'll take for the training the model, and other one is the test part, which we'll take while testing the trained model. So 80% data we'll be using for training the model, and 20% data we'll be using for testing the trained model. So over here, if you see, we are talking about variable x and y. So x is an independent variable. Increasing age is natural phenomena, and so it is independent. And in the similar way, mileage is also an independent variable, because as a car moves, mileage will automatically increase. Therefore, age and mileage both are the independent variables. And the sale price is the dependent variable. As I have told you, sale price depends on the mileage as well as on the age. So now we'll have to split the data, the complete data set, into x and y. For that, we are going to use train test split function, and we'll perform this program in uh, pandas. So for pandas, we'll be using collab.googleresearch.com. So see here. So how to use train test split? For using train test split, because this is from scikit class. So to use train test split, we'll have to import it. So how to import it? So this is the statement from sklearn.model slash import train test splits. So from this library, we will be using train test split function. So it will divide or split the entire data into four data sets: xtrain, xtest, ytrain, and ytest. So this is the format: xtrain comma xtest, ytrain comma ytest is equal to train test split these two variables, independent and dependent, and test size 30.30. It means 30% we are taking data as the test data, and 70% data we are taking as the train data. So it indicates that 70% of whole data will be used to train the model and 30% data to test the trained model. Okay, so now it's time to train the model on the basis of the linear regression. Therefore, again, we'll have to import new function, that is linear regression. So this is a statement from sklearn.linear model import linear regression, and we are going to create the object LR is equal to linear regression. This is a function, and now we are going to train the model. So how to train the model? So I have taken another variable mod tr is equal to linear regression dot fit. So fit function will train the model. So here we'll have to mention xtrain and ytrain. So now getting the prediction by applying a test, that is x test on trained model. So what should be the format? The format should be mod trained dot predict x test. So x test we already have 20% or 30%, whatever, and we have trained the model using lr dot fit. Okay, so without wasting much time on this discussion, we'll move to our collab. So here we have our collab. I'm just increasing the size. It's fine. It's a fine. So I have imported pandas as PD. Import matplotlib.pyplot as PLT, and percent matplotlib inline, so that your graph should be plotted in the same sheet, same window. And first of all, I would like to execute this so that pandas be imported and matplotlib be imported. Fine. Then I have taken the data which I have shown in the slide presentation, car prices.csv. So this way I am going to create the data frame. So this is a data frame and printing the data frame df. So over here, if you see, this is the entire data frame. Okay. So out of these four columns, age, sale price, mileage, and car model, we don't require car model because we have to work on mileage and like dependent variable and independent variable. So here dependent variable is sale price and independent variables are mileage and age. So how to delete the column car model? So to delete the car model, I have used df is equal to df dot drop columns is equal to car model and x is equal to 1. Now if I click this and print df, it will show you three columns only: mileage, sale price, age. Now getting the relation between mileage and sale price. So as far as graph is concerned, so I am going to create a scatter graph on mileage and sale price. So how to create it? So PLT. So PLT is matplotlib variable, and I'm going to create the scatter graph using PLT dot scatter. So we have two variables here. One is for x-axis and other for the y-axis. So I'm taking mileage for x-axis and sale price on y-axis. So as soon as I run this function, a graph is created like this. And if you see, this is y-axis and horizontal is the x-axis. Okay, so horizontally we see the mileage and vertically we see the prices. So if the mileage is 90, then or more than 90, then prices will be less. So see here, it is below 15,000. If the mileage is 70,000 or also more or less 70,000 or 71,000, the car price could be 20,000 and around. Similarly, we can create another plot in age and sale price. So with the age, sale price will also be reduced. So here, if you see, if the age is 8, then sale price is bare minimum, means below 15,000. Similarly, if the age is around 6 years, its price could be between 20,000 or 21,000. So this shows the complete uh, diagram on mileage and age and sale price. Now we are going to train the model here. And before train the model, we'll have to split the data. So how to split the data? So we have taken from sklearn model selection, import TrainTest split and apply this function to split the data. So I have taken x and y, these two variables. One is independent variable and other is dependent variable, and testing size is 30%. No issue. So if you run this, okay, there could be the problem because these have to be executed. So what is independent variable? So this is a value of independent variable, mileage and age, and this is the dependent variable. So here this is. Now I'm importing TrainTest split function. So see here, so TrainTest split function has been imported and applied to xtrain, xtest, ytrain, and ytest, and we have split the entire data into two, x and y, and testing size is 30%, 0.3. So when we divide the entire data, we observe that independent data is 13, total size of the data is 13 rows, and out of 70% is your train data. So 70% is your train data and 30% is for test data. So 9 and 4. So this is for training data and this is for testing data. So what is xtrain? So xtrain, there are 9 rows. 5, 6, 7, 8 and 9. So it has taken randomly 9 rows, and for testing data it has only 4 rows. So randomly it has taken. Okay, now this time to train the model. So how to train the model? So we'll have to import another function, linear regression. So how to import it? The same library sklearn, I am going to import this. So from sklearn dot learn linear model, import linear regression. So this function is imported from sklearn.linear model, and now I am going to create an object of linear regression. So LRM, suppose this is my object, and now this is time to train the model. So LRM is the linear regression model, and on the basis of this model I'm going to train the data. So training data is xtrain, and this is independent data, and y is the dependent data. So both training data I'll have to mention along with the fit function, and this will train the model. And after training the model we have to test it. So what is test model? So test data is your four rows. So here you see mileage 69,000, 6 years 46,000 and a. And if you see predict, apply prediction. So since you have four items or four samples in test data, so LRM dot predict on X test. So I am going to predict on the trained model and using the X test data. So over here, if you see 91,000 mileage, and after 8 years, it is showing test data is, it shows that 15,000 point something. Similarly, when the mileage is 59,000 and age is 5,000, it is 26,916, 917 and so on. So there are four data sets after prediction. If you print them like X test and Y test, then you'll see the score between these two after testing. So X test and Y test, the if score is coming to 91, means 91%. So far better. And if you want to change, you can change the model test size. So I am taking test size 0.3, I am taking test size 20%, and train size is 80%. So if you run this and then find the length will be train size is 10 and test size is 3. So this is 20% of 13. 20% of 13, this is 80% of 13. So xtrain like 10 rows, 10 data samples, and test 3 data samples. So now create the linear regression. Linear regression is created, and then train the model. The model is trained. So what is X text? So samples are 3 only here, and it is, though it is not required, is still. So 3 samples are here. Now you can predict. So after prediction, you'll see 26. You can say uh, after 5 years of age and mileage of 52,000, the current price should be 26,635, and the mileage, if mileage is 35,000 and 3 years of age, so its price should be, its prediction is coming wrong, I think a bit. This is X test, and let's see the Y test also. Okay, we have used data. This is X test. So in age, so it, if it shows, okay, so there is a problem. So we'll have to do it again. So instead of taking 20%, we should take at least 25%. So 0.25 I'm going to take. Okay, length is 13. This is 9, and test 4. And now train the model. Train the model. And so here this is training model. And after training, what is the test data? And what is the prediction? What is the prediction? So prediction is like this. If mileage is 22,000, after 2 years, the price should have been 44,000 and 69,000. Then the price should be 24,000. It is showing this data is a bit confusing. But if you see the score, let's see the score. So score is somewhat correct, but not as per our prediction or as per our desire. So I'm taking it as only 1, 10%. Okay, so train data is how much? 11, and test is 2, and now create the linear regression, and after linear regression train the model. So model is trained, and what should be the X test? So after 6 years mileage is this, then the price should be after 6 years and mileage 67,000, the prediction should be this much. So after 6 years, the car price should be 23,925, and after 4 years, this car price should be 31,926. So this way, your model is perfectly trained, and if you find out the score, evaluate the score, this is quite good. 91% is your prediction, so it is correct. So this way we can train the model and predict the prices and car prices. So hope you are clear with the 10 test split function and sklearn model selection and sklearn linear model. So that's all for today. So we'll meet in the next video. Till then, bye bye.